Elon Musk, the visionary entrepreneur behind Tesla and SpaceX, harbors a bold ambition to establish a permanent human colony on Mars. Driven by a belief that humanity must become a multiplanetary species to survive, Musk envisions a future where humans inhabit not just Earth, but also the Red Planet. He paints a picture of a self-sustaining Martian city, a testament to human ingenuity and resilience. This audacious goal, while captivating the imaginations of many, has also sparked intense debate about its feasibility and the immense challenges it presents. Musk's vision extends beyond mere survival. He sees Mars as a blank canvas for a new society, one free from the constraints and baggage of Earth. This Martian civilization would be built on innovation and exploration, pushing the boundaries of human knowledge and capability. The ambition is grand, the stakes are high, and the questions are many. Is colonizing Mars truly achievable, or is it a fantastical dream destined to remain out of reach? Before humans can even contemplate settling on Mars, the fundamental question of its habitability must be addressed. The Red Planet, while holding a certain allure, presents a hostile and unforgiving environment. Its thin atmosphere, composed primarily of carbon dioxide, offers little protection from the harsh radiation bombarding the surface from the sun and deep space. Temperatures on Mars fluctuate wildly, plunging to bone-chilling lows of minus 143 degrees Celsius at night and rising to a comparatively balmy 20 degrees Celsius during the day. These extreme conditions pose significant challenges for human survival, requiring advanced life support systems and protective habitats. Moreover, the availability of liquid water, essential for all known life, remains uncertain. While evidence suggests the presence of ice at the Martian poles and beneath the surface, accessing and utilizing this resource would be a major undertaking. Growing food on Mars, another crucial aspect of a self-sustaining colony, would necessitate innovative agricultural techniques adapted to the planet's thin atmosphere and lack of organic nutrients. The challenges of making Mars habitable are daunting, requiring significant technological advancements and a deep understanding of the planet's unique environment. The journey to Mars and the subsequent challenges of living on its surface are fraught with dangers. The vast distance between Earth and Mars, ranging from 54.6 million to 401 million kilometers depending on their orbits, translates to a months-long journey through the unforgiving vacuum of space. During this perilous voyage, astronauts would be exposed to high levels of cosmic radiation, increasing their risk of cancer and other health problems. The spacecraft itself would need to be shielded against radiation and equipped with robust life support systems to ensure the crew's survival. Landing on Mars presents another significant hurdle. The planet's thin atmosphere provides little resistance for spacecraft, requiring complex landing procedures to slow down from high speeds. Once on the surface, colonists would face the constant threat of dust storms, which can engulf the entire planet and last for months. Martian dust, fine as talcum powder and containing harmful chemicals, poses serious health risks if inhaled, potentially damaging the lungs, kidneys, and other organs. Overcoming these challenges is paramount to ensuring the safety and well-being of future Martian inhabitants. The Martian environment is a relentless adversary, presenting a range of hazards that could jeopardize the survival of any human colony. One of the most visible and potentially dangerous phenomena is the ubiquitous dust storms. These storms, driven by the planet's extreme temperature variations, can whip up fine dust particles into a frenzy, creating towering dust devils and planet-encompassing dust clouds that block out the sun for months on end. While not a direct threat to human life, these storms pose significant challenges for solar-powered equipment, communication systems, and outdoor activities. Even more insidious is the invisible threat of radiation. Unlike Earth, Mars lacks a global magnetic field and a thick atmosphere to deflect harmful cosmic rays and solar flares. This constant bombardment of radiation poses a significant health risk to humans, increasing their chances of developing cancer, cataracts, and other radiation-related illnesses. Long-term exposure to Martian radiation could have detrimental effects on human health and reproduction, making it essential to develop effective shielding mechanisms and radiation-resistant habitats for future colonists. Section 5. A wrench in the gears: resource constraints. The dream of colonizing Mars faces not only technological and environmental hurdles but also geopolitical and resource constraints that could hinder progress. One such challenge arises from the increasing global demand for rare earth elements, crucial components in advanced technologies including spacecraft, electronics, and renewable energy systems. China, which currently dominates the production and export of these elements, has recently implemented stricter regulations on their mining and export, citing environmental concerns and strategic resource management. This move has sent ripples through various industries, including the aerospace sector, which relies heavily on rare earth elements for critical components. SpaceX, with its ambitious Mars colonization plans, would undoubtedly require vast quantities of these elements for its Starship fleet, habitats, and other technologies. The restricted access to these resources could potentially impact the timeline and feasibility of Musk's vision, highlighting the interconnectedness of global resource management and the pursuit of space exploration. Section 6. Doubters and dissenters. Skepticism abounds. Elon Musk's ambitious plans for Mars colonization have not been met with universal acclaim. Skeptics, including scientists, engineers, and even fellow tech billionaires, have raised concerns about the feasibility, cost, and ethical implications of establishing a human colony on another planet. Critics argue that the challenges of making Mars habitable are insurmountable, at least with current technology and resources. They point to the lack of a breathable atmosphere, the extreme temperatures, the constant radiation bombardment, and the psychological toll of living in a confined and isolated environment as major obstacles. Bill Gates, co-founder of Microsoft and a prominent philanthropist, has publicly expressed his doubts about Mars colonization, suggesting that investing in solutions for Earth's problems should take priority. He argues that the resources required for such an endeavor could be better spent addressing climate change, poverty, and disease here on Earth. These dissenting voices highlight the need for a balanced and nuanced discussion about the merits and drawbacks of Mars colonization, considering both the potential benefits and the significant challenges involved. Section 7. Countdown to launch. SpaceX charts the course. Undeterred by the skepticism and challenges, SpaceX, under Musk's leadership, continues to make strides towards realizing the vision of Mars colonization. The company's Starship program, designed to develop a fully reusable spacecraft capable of transporting humans and cargo to Mars and beyond, is central to this endeavor. Starship, conceived as a massive two-stage spacecraft, aims to revolutionize space travel by significantly reducing costs and enabling frequent missions to Mars. Beyond the spacecraft itself, SpaceX is also developing other crucial technologies for Mars colonization, including habitats designed to protect colonists from the harsh Martian environment, spacesuits equipped for exploration and resource gathering, and innovative life support systems to provide breathable air, water, and food. While the timeline for establishing a permanent human presence on Mars remains fluid, SpaceX's ambitious plans and relentless pursuit of technological innovation continue to push the boundaries of space exploration. Section 8. Earthly concerns. Should we leave home at all? The allure of colonizing Mars, of becoming a multiplanetary species, often overshadows a crucial question. Should we be focusing our efforts on leaving Earth at all? Critics argue that instead of pouring resources into escaping our planet, we should prioritize solving the pressing issues threatening our existence here on Earth. Climate change, pollution, resource depletion, and social inequalities demand immediate attention and could ultimately render our own planet uninhabitable if left unchecked. Furthermore, the ethical implications of colonizing another planet raise complex questions about our responsibility to potential Martian life, the potential for environmental contamination, and the long-term consequences of altering another celestial body for human habitation. These concerns highlight the need for a broader ethical framework to guide our actions in space, ensuring that our pursuit of cosmic aspirations does not come at the expense of our home planet or the potential life it may harbor. Section 9. A Future Among the Stars, a Balanced Perspective. Elon Musk's vision for Mars colonization has ignited imaginations and sparked a global conversation about the future of humanity. While the dream of settling on Mars is captivating, it's crucial to approach this endeavor with a balanced perspective, acknowledging both the immense challenges and the potential rewards. The technological hurdles are significant, the environmental hazards are formidable, and the ethical considerations are profound. Yet the human spirit of exploration, innovation, and resilience should not be underestimated. The pursuit of knowledge, the drive to push the boundaries of what's possible, and the desire to secure a future for humanity beyond Earth are powerful motivators. Whether or not Mars colonization ultimately proves successful, the journey itself will undoubtedly lead to groundbreaking discoveries, technological advancements, and a deeper understanding of our place in the cosmos. As we venture further into the unknown, let us proceed with both boldness and humility, ensuring that our cosmic aspirations align with our responsibilities to our home planet and the generations that will inherit it. Thank you for watching. If you enjoyed this video, please like, comment, and subscribe for more content on space exploration and beyond.